Oops, sorry. Hi calculus, welcome to 7.3, or sorry, 7.4. This is the fundamental theorem of calculus. And what this is we're getting rid of the c's now. We're going to do integration. So we're going to do antiderivative with integrals where we actually get numbers instead of equations for our answers. So let's go. All right, what the fundamental theorem of calculus does is it takes the integral of our function. To do our integral, we do the antiderivative of f of x, and then we plug in the numbers that are usually on the a and b. And this gives you a value basically under a curve. So here we have, I want to find the value of 3x squared dx from 1 to 3. In order to do this, you take the antiderivative of 3x squared. Well, here you just add and divide, so we know that that used to be x cubed plus c. Now the c disappears since I'm going to give it a value from 1 to 3. So now we use the x cubed from 3 to 1, and we plug in the 3 cubed minus the bottom value, and this equals 26. That's the area under that curve of the 3x squared. Okay, pause and try yours. So you should have had x to the 4th. You're going to go from 2 to 1. So you're going to take 2 to the 4th minus 1 to the 4th, which equals 16 minus 1, which is 15. So the area of 4x cubed from 1 to 2 is 15 units. That's what that is. All right, a few rules. Just so you know, if there's a constant, you can always pull it out front. Nothing new. If you have two separate ones, you can do them individually. If you're going from the same number to the same number, that's going to equal 0 because there's no area. If you have two of them that you need to break up, you can break them up like a to c and then c to b, as long as these two numbers are the same. And it gives you the area for both of those combined, which we will be doing in a little bit. If you accidentally flip the way you subtract, you just get the negative of the answer. All right. Here we go. We want to find the area of 2x cubed minus 3x plus 4 from 3 to 5, and that's between that graph and the x-axis is what we're doing. So we're going to do all these rules even though you don't need to do them all. So we're going to take 2x cubed, and I'm going to pull out the 2. The 3x, I'm going to pull out the negative 3. The 4, I'm going to pull out the 4. Antiderivative. So this is x to the 4th over 4. I have x squared over 2. And this one here is just x. Now, I can reduce these, the 2 and the 4, and get 1/2, and pull him out front if I want to. So then that is just 5 goes in here, 5 to the 4th minus 3 to the 4th. Pull the 3/2 out, 5 squared minus 3 squared. Pull the 4 out, 5 minus 3. Plug that in your calculator, and you get 256. Okay, it's your turn. Pause and give it a shot. So you should be doing 6 from 2 to 5, x squared dx minus 3 from 2 to 5 of x plus 5 integral 2 to 5 dx. Do your antiderivatives. So this is x cubed over 3, still times 6, all from 2 to 5. Minus 3 x squared over 2, all from 2 to 5, plus 5x, all from 2 to 5. Now we could leave those numbers in there and work them, or pull them out. We're pulling them out here just for ease. So we know that 6 and 3 cancel to 2. So this is really 2. Now plug in your values. 5 cubed minus 2 cubed. All right, minus, I'm going to pull out the value again. Don't have to, but you can. 5 squared minus 2 squared. Plus 5 times 5 minus 2. All we did was we plug in the 5 and the 2 each time. Plug that in your calculator, and you should get 217.5. Okay, I hope you did well. Next, we got to look at some of those weird ones again. Remember e and the natural log? So remember, this is really the integral from 1 to 2 of y to the negative 1 dy. Well, we know the antiderivative of y to the negative 1 is natural log of y. all from 1 to 2. Then we just plug in the 2. So the natural log of 2 minus the natural log of 1, 0.69. Your turn. Okay, I would have pulled out the 2. Integral 1 to 3 of y to the negative 1 dy. So you know that equals to 2 times the natural log of y, all from 1 to 3. So that is equal to 2 times the natural log of 3 minus the natural log of 1. Type that into your calculator and you should get 2.1972. Alright, let's do a little bit more fun. These here are more interesting. Now we have two things times each other. So remember that product rule and our chain rule? All of that comes into play. So now we've got x, and I'm going to rewrite it as to the 1/2. I'm going to rewrite this again over here because I have to have the derivative back here in order to do the function. Remember, it's f of x dx. The derivative has to exist. So let's rewrite this problem. This is 0 to 5. I'm going to put 25 minus x squared to the 1/2 here. Now I have to have the derivative of 25 minus x squared back here. Currently, I have an x and I have a dx. Well, the derivative of 25 negative x squared is negative 2x. That means I need to multiply by a negative 2 here in order to get my complete derivative that I need. But if I'm multiplying by negative 2, I have to put negative 1/2 on the outside to keep my balance, because negative 2 times negative 1/2 is 1. So that's where this came from. I hope that helps you. Once I have this, now I can integrate this problem. So we're going to do the antiderivative of this. So we're going to take 3/2 power divided by 3/2. Well, we all know better than that, right? We don't divide by 3/2, we multiply by 2/3. So that is technically negative 1/3. So now we have negative 1/3, 25, minus x squared to the 3/2 power, all from 0 to 5. All right, you can do this with the fraction or without the fraction. It doesn't really matter. Okay, now these are the exact same thing. I just wrote them out differently. If you plug in the 5, that's 25 minus 25, which is 0. Now I have to subtract, so I'm subtracting negative 1/3 times, plug in the 0, 25 to the 3/2 power, which is a negative 125 over 3. Plug that in your calculator, and you get 41.67. All right, pause and try yours. Step 1, rewrite. So we're going to put 0 to 4. We're going to put 16 minus x squared to the 1/2 power. We're going to put this together. So I've got 2x dx currently. So now the derivative, 16 minus x squared, is negative 2x. So I need a negative 2x, which means I got to multiply by a negative here in order to match, dx, in order to match. And I need a negative 1 here, so I keep my balance. I have my derivative, so now I can do the antiderivative. So this is 16 minus x squared to the 3/2 power. We're going to multiply by 2/3 instead of dividing by 3/2. So that's going to be a negative 2/3 on the outside, all from 0 to 4. All right, so let's plug this in. So now I got a negative 2/3, and I'm just going to leave it on the outside right now. If I plug in 4, that is 16 minus 16. So this is 0. He goes away. Minus. Now we're going to plug in 0. So that's 16, 2. So the 0 goes in here. So it's 16 minus 0, all to the 2/3 power. I should have written that one over there too. All right, so 16 to, oh my word, 3/2 power. I am so sorry, children. 3/2 power. All right, type that all into your calculator and you will get, so you take a negative 2/3 times negative 16 to the 3/2 power, and you should get 42.67. I hope you did a great job. All right, this is where it gets tricky. Here's my x squared minus 4 is just a parabola moved down 4. I need to know the area between the parabola and the x-axis. Now, if we do between 0 and 2, it's not too bad. It's all in the same spot, right? It's just right here. So that's easy enough. And we do the antiderivative. Antiderivative of x squared is x cubed minus 3. Antiderivative of 4 is 4x. We go from 0 to 2. We plug it in, but we get a negative. That's because it's underneath the axis, but we know the area cannot be a negative, so we take the absolute value of that, giving us 16/3. All right, try yours. So you should have had x cubed over 3, all from 3 to 1, minus 3x squared over 2, all from 3 to 1. You're going to type in your 3 to 1, so you're going to get 3 cubed over 3 minus 1 cubed over 3 for the first one, minus, we can leave it, I'm going to leave it in this time. So this is 3 times 3 squared over 2 minus 3 times 1 squared over 2. All right, I hope you did a good job there. Type all those in to your calculator and you should have gotten a negative 10/3. But it has to be absolute value, which gives you 10/3 or 3.3 repeating. Okay, the other way you could have done it, which I'll show here also, we could have taken out the 1/3 and see how it makes it just a little bit easier. Now that is 3 cubed minus 1 cubed. Right? So we got 26/3 minus, now let's take the 3 halves out. And that is 3 squared minus 1 squared. So 3 halves times 8. Pretty easy, right? You get the exact same answer. It's still negative 10/3. Absolute value is still 10/3. Either way, perfectly fine. Do the one you like best. All right, now we're going to make this a little bit trickier. Same graph, but now I want to go from 0 to 4. Well, when you look here, okay, the 0 to 2 is under the x-axis, but the 2 to 4 is above the x-axis. So we really have two different areas we have to find and add them together. All right, to do that, first we have to figure out where it crosses the x-axis so we know what we have to divide our integral in between. So to do that, we set this equal to 0. We set it equal to 0, so you got x squared equals 4, square root, and we get plus or minus 2. But we're only going from 0 to 4, so the negative 2 is not necessary. So the 2 is in the middle of these things. So this is what we use for our integrals. 0 to 2, and 4 to 2. 0 to 2 for the first one, 2 to 4 for the second. See how the 2's match? Very important, because that's where our division is for our area. Our antiderivative, x cubed over 3 minus 4x from 2 to 0. X cubed over 3 minus 4x, nothing different, but from 4 to 2. Now we plug in our 2. So we've got 2 cubed over 3 minus 8. This guy technically should have been first. And then we should have subtracted. All right, this should look like this. 8/3 minus 8. All right, and then minus, plug in 0, and that's 0. Plus, we're going to plug in our 4. So we've got 4 cubed over 3 minus 4 times 4, right? This minus 2 cubed over 3 minus 4 times 2. All right, now we got our parentheses all in the right spot. Type that onto the calculator, and you actually get 16. Do not forget that this is negative right here. That has to be made positive. Okay, so if you don't have a calculator that does that, you type that section in first. So you take the 8/3 minus the 8, and you make it positive. I don't think I've actually done that yet here, clearly. So this is actually a negative 16 thirds. Whoops. But you're going to type in 16 thirds plus. And you're going to use the rest of your values. All right. I hope you did a good job on that and you got your 16 for your answer. Okay. Pause and try yours. Step 1. You should have set it equal to 0. So x squared equals 9. So x equals plus or minus 3. 0 to 6, our interval is going to go from 0 to 3, and then 3 to 6. So now we're going to go 3 to 0, x squared minus 9 dx, plus 3 to 6, 3 is matching, right? From x squared minus 9 dx, your antiderivatives are x cubed over 3 minus 9x from 0 to 3 plus, oops. Wow, come on, stop that. I don't know why it's being weird. All right, let's try this again. X cubed over 3 minus 9x, all from 3 to 6. Type in your numbers. So you've got 3 cubed over 3 minus 9 times 3. And when you plug in 0, you're going to get 0. So you're subtracting 0 from that for your first section. Plus 6 cubed over 3 minus 9 times 6. That answer. Get it right tonight. Minus 3 cubed over 3 minus 9 times 3. All right, so this entire section, so those are the two areas we're adding up. Well, when you type in this area, you should have gotten a negative 18. So we have to do the absolute value of that, so that's 18 plus. Now when you did the area of this entire section right here, you should have gotten 18 minus a negative 18, which is 36. And that will give you a total area of 54. All right, I hope you did a great job. Good luck on your homework. Make sure you're posting questions if you have any. See you soon.